Hello students, this lecture will be on null hypothesis, statistical testing and p-value and how to use it. So we get some results and we have some theory and we want to test our assumptions. In this way we must state some of them, and if there is no difference or nothing changes in this world where the assumption is correct or null hypothesis, then we state that it's okay to get these results, but with some probability. And this probability characterizes our survey. So, p-value characterizes how our data is used and how it against the null hypothesis. The less probability of obtaining our data if null hypothesis is true, then of course the more chance we have to reject null hypothesis. It doesn't mean that it's false, but it only states that we can reject this hypothesis. And in other case, if probability to obtain this data is more than level of significance that is often used by 0.05 or 5%, then we fail to reject null hypothesis, but it doesn't mean that it's true. It's only a probability that by some chance or some noise we get incorrect data that don't prove our hypothesis. So if we get to the Gauss curve as it was on previous lecture, and I tried to explain it. So this is probability line from 0 to 1, and then our curve. You see, in this axis we have probability p, and then we have some value of statistic z or z criteria. We have area, will be shading, and its square is consisted of 5% of all square of our probability. And so if we get that in this area of our data, so we can reject our null hypothesis. And if we have data or value calculated by data that is in this area, so we have to fail to reject the null hypothesis, say that it's okay to under that circumstances to obtain this data. So the lesson on p-value is over. See you next time.